In this video, we will demonstrate the end-to-end process of developing a new probe. This will include defining inventory, metrics, and bulk configuration in probe schema XML, writing the code required to produce inventory and metrics, and finally demonstrating the finished probe by deploying it to a robot. The probe we build is going to demonstrate the basics of producing inventory, metrics, and probe-oriented bulk configuration. This probe is going to be called VM Simple and is going to demonstrate a very simplistic VM environment monitoring. The inventory produced by the probe is as shown here. A resource profile will have many VM hosts attached to it. Each VM host can have many VM guests, and each VM guest can have many CPUs. The probe will produce only 4 metrics. For each VM host, we'll report the guest count and CPU usage. For each guest, we will report the CPU count, and for each CPU associated with a guest, we will report the CPU load. This probe is a good use case for probe-oriented bulk configuration because configuring static monitors for each guest and metric would be labor-intensive and would not scale well. We will configure the POBC template definition to recognize the inventory structure and provide the ability to filter on hosts and guests. To get started, we need to create a new probe project from one of the provided templates provided by the SDK. I've opened up a command prompt in the location where I wish to create this new project, and I'm going to issue the Maven archetype generate command. This command will start the process of creating a new probe project from one of the templates provided by the SDK. Since we are creating a remote probe that's going to support probe-oriented bulk configuration, I need to choose the first template. For group ID, I'm going to enter com.ca. Artifact ID is going to be the name of the probe, which we said is going to be named VM Simple. I'm going to accept the default version, and for the package, I'm going to enter com/nimsoft Probe SDK example. The project has now been generated, and now let's open it up in Eclipse so we can start modifying it. I have started Eclipse, and to open up the project I simply have to import it as an existing Maven project. With the project open in Eclipse, I can now modify Probe Schema XML for our inventory, metrics, and bulk configuration. Probe Schema XML can be found in the Source Main Resources folder. To start with, I want to remove the stubbed out elements that were provided by the template. And I also want to remove the stubbed out template definition so we can provide our own. What we are left with is just the resource response time for the resource which is required. We are now at a point where we need to create our inventory elements to represent VM hosts, guests, and CPU. At this point, it's always a good idea to look at the Probe SDK Java doc so that you can see what elements are available for modeling inventory. Let's bring that up. The Java doc is shipped in the Probe SDK in the docs directory. Here we see the Java doc. Notice there's about 6 packages displayed. The package we are interested in is the inventory package, and there's a nice overview package level Java doc that we can read to get a good overview of all the inventory elements. An important thing to notice in the summary of each of the classes is make note of whether it's an IP addressable component or a non-IP addressable component. And then there's one special element in here called a folder. A folder is not actually an element, but it's just a way that you can group things in the UI. We'll demonstrate that in a moment. Also, please take time to read the description under the package level Java doc. So the elements that we're going to use for modeling our inventory for this probe is computer system element. We will use computer system element to model our VM host. For VM guest, we will model that as a virtual system element listed near the bottom there. And for the CPU, we will use the processor element. Let's go back to our probe schema XML file and start filling this out. Okay, first, let's specify the element for the VM host. Here we specify the VM host element. We can see that the base element type is the computer system element that we identified from the Java doc. We are specifying that for the icon in the UI, we want to use the server icon, and then we've defined the two metric types that we want to have associated with the VM host. We've defined the guest count and the CPU usage. Next, let's do the VM guest element definition. Here's the VM guest element definition using the virtual system element that we identified in the Java doc. It's using the VM active icon, and we have one QoS metric named CPU count defined. And finally, let's define the last element, which is the VM guest CPU. Here we see the base element type is processor element, as we specified we were going to use, and we have the CPU icon being used, and our one QoS metric is CPU load. We have finished defining our inventory elements and our metrics. The next step is to define our bulk template definition. To create a POBC template definition, we must model the relationships between our inventory elements and specify what filters we want on each element. Let me enter the template definition now. Here we see the complete template definition that we want to use for this probe. Note how we model the parent-child relationships between the elements, and also note the filters that we've applied to the VM host element and the VM guest element. We've now completed our modifications to probe schema XML, and at this point it's a good practice to make sure that the elements we defined get automatically generated. You can do that by rebuilding the project. The generated sources will then be available in target generated sources main Java, and here we see them. We see we have a VM guest, a VM host, and a VM guest CPU elements. Take a quick look at these. We won't need to modify these. We just need to be aware of the connection between the elements we define in probe schema and how Java classes get defined for us, because then we're going to use these classes to model our inventory. The next thing we need to do is start modifying the provided code in the primary Java class, which is called probe main. Let's open that up. There's three main areas we need to do work here. We need to modify the method add default configuration to graph. There's another method called test resource, and there's another method called get updated inventory. Let's talk about those one at a time. So add default probe configuration to graph. This is where you configure what you want to display in the probe configuration UI with regards to profile actions and profile properties. The template already gives us a really good start here by providing the actions and properties that are typically needed for a remote probe. We can see that at lines 70, 71, and 72, we add some standard actions to add, delete, and verify a profile. And then the remainder of the method adds some standard properties that are typically needed with remote probes. We can see at line 79 we're adding the host, followed by the port, username, and password, and then we also add the alarm message interval and active properties. So for a lot of remote probes, the probe developer will be able to just use this as it is. For this particular probe that we're building for this demo, we don't need any additional properties or actions, so we don't need to modify anything here. So this is good. Next, let's take a look at the test resource method. The test resource is an opportunity to verify a profile configuration prior to the probe starting its collection cycles. This is invoked when the user is using the probe configuration UI and they click on the verify resource link. This gives the probe developer an opportunity to collect the properties set in the profile and verify connectivity. For this example, I'd like to verify the host, port, username, and password actually allow me to connect to my mock VM environments. So here's how I do that. First, we've got this little placeholder here saying insert your test logic here. We can delete this. This is just some instructions to remind the developer what needs to be done here. And it says, if the test fails, you can report an error by throwing a NIM exception. However, if the test is successful, you don't need to do anything. You simply need to return null. So let's start by deleting this. Let me add a couple lines of code that allow me to pull out the host, port, user, and password out of the resource configuration. So these 4 lines of code show how to retrieve properties from the resource. And in here we're pulling out the host, port, username, and password. So the next thing I would want to do is I would want to use the host, port, username, and password to actually connect to the device that I am monitoring. This is where we go beyond the scope of the probe framework and we start having to implement domain-specific logic. The probe framework doesn't know anything about the specifics of how you need to communicate with the device under test. So it doesn't offer any assistance or doesn't place any restrictions. So here you can use standard Java techniques to communicate with the device. So what I'm going to do for this is I just want to make a log message so that we can see that our method's getting called when we expect it's getting called and that we're verifying. And I'm going to put a to-do to actually add in the logic to actually go off and communicate with that device. The next and the last thing we need to do is we need to build up our inventory and metrics in the getUpdatedInventory method. Here is the getUpdatedInventory method. This is called by the framework on the inventory collection cycle. This is where we construct the inventory, attach metrics, and we let the framework then determine which ones to publish based on how the probe is configured. Note that the framework passes in the resource configuration and it provides a placeholder here saying insert your logic for populating the inventory data set here. There's a couple example lines of code, so we're going to delete these couple example lines of code and add our logic. So one of the first things that I probably need to do is I'm going to need the username, host, port, and password. This should look familiar because this is the same code that we used in test resource to obtain the host, port, username, and password. I would then use these credentials to create a connection to the device under test, gather the metrics, and then the next thing I would need to do is publish that inventory and metrics in a form that UIM expects. To save time, let's just go ahead and create a little bit of sample data that's representative of what this data would look like. So let's create a method called createMockDataset. And what this is going to do is this is going to return just a little bit of data so we can verify that we're constructing the inventory in the correct manner and test our results. So the first thing we need to do when creating a data set is we need to construct a new inventory data set passing in the resource config. And ultimately this is what we would return. So we've got this method stubbed out. And we can call it with this line of code. Let's now add just a few lines of code to build up the data set as we specified it's going to look like. First, let's create a folder to group our VM hosts in. And so this is where we're using that folder elements that we saw in the Java doc, and we're attaching it to the resource config. Now we want to create our first VM host. This is how we create a VM host element, and we add it to the host folder. Now, if we were collecting real data here, we would have many of these, but for this example, I'm just going to do one just to show it. Under each VM host, recall that we can have one or more VM guests. So let's create a folder called guest folder that we will attach to that particular VM host, and this is where now we can populate this folder with one or more VM guests. So here's what the code looks like to add one guest to the guest folder. And finally, let's attach a CPU to that guest. That completes a simple example of what this data set is going to look like. The only difference between this and if we were doing this for real is we would be dynamically generating many hosts, many guests, many CPUs based on the data we collected. But this shows in a very simple manner the mechanics of creating inventory elements. And finally, let's see how we would set the metrics on these items. Recall that we just have 4 metrics. Setting the metrics would look like this. For host, we set 2 metrics, CPU usage and guest count. For our guests, we have just 1 metric, and for the guest CPU, we're setting 1 metric. This is just a little sample data so that we can do a prototype proof of concept to make sure that we're constructing our inventory in the manner we want to, because this gives us something to test. So that completes the development. At this point, we should be able to build, package, and deploy the probe. Let's go to the command line and do a Maven install to build this probe. Here we are in the probe directory, and the command I want to give is Maven install. The build was successful. We can find our probe distribution in the target directory. VM simple target. And here's the probe. We can now deploy this to a robot and test it and see how our metrics look. Make sure it's what we want. And then the next step would be to go back to the probe code and remove that little bit of hard-coded inventory generation and replace it with actual logic that dynamically goes out, talks to our device under test, and builds up the full inventory. Now that we have finished the initial development of the probe, including the simple hard-coded inventory, the next thing we want to do is test the probe by deploying it to a robot. This will give us an opportunity to verify the probe-oriented bulk config template configuration, as well as how the inventory and metrics are being published. Let's log into Admin Console, upload the probe to the archive, and deploy it. And momentarily the probe will be available on the robot. The probe has been deployed. Let's now go into the configuration UI and see how it looks. Let's start by verifying we can configure a POBC template. Notice the template editor button up here in the corner. This is enabled because we chose the Maven archetype template for probe-oriented bulk configuration. If we had not have chose that template, this button would not appear in the UI. So I'm going to create a new template. And the first thing I want to verify is that the hierarchy is what I was expecting. Note the hierarchy over on the left. This matches what we configured in Probe Schema XML in the template definition section. Let me pull that up just for reference. So here is our template definition that we defined, and note that we have at the top level VM host, and its child is VM guest, and its child is VM guest CPU. And note that we can apply filters at the VM host and VM guest level. Let's go back and see how that looks in the UI. Here we can see that everything looks correct. We have VM host, we have the ability to filter on that, we have VM guests, and we have the ability to filter on that as well. I'm going to go ahead and turn on some monitors so that when we configure a profile, the probe will actually produce some measurements. So I'm going to turn on the CPU load measurement. I'm going to turn on the CPU count measurement, as well as the two measurements that are on a VM host, which is CPU usage and guest count. Alright, let's go ahead and save that. That's the end of the template configuration. Let's go back and configure a profile for our probe. Now recall that since we hard-coded our inventory, that we're not actually going to try to communicate with an external host, so whatever data we put in here is not going to be used except for that log message that we put in the test resource. Let's see how that would show up. So for host name, I'm going to make up a name. We'll leave the port at that. We'll say test user 1. And I'm going to put this a very quick inventory collection cycle so that we can actually see some measurements being produced. Now I have the opportunity to test this information. I can test this here in actions. When I select my profile setup, I can say actions verify selection. This invokes the logic that we wrote in the test resource section. Let's go look at the log, and we should see a log message saying that that was called. So first I'm going to go back to the source code so we can see what log message we're looking for. Here's the log message that we're looking for, line 129. We're looking for a log message saying verify and connectivity to host, and then it should tell us the host, the port, and the username that we added in. So I'm going to view the log. Okay, I see here is the message we are looking for at the very bottom. It says verifying connectivity to host, test host, port 443, user, test user 1. And it even has my typo because I didn't type in test user 1 correctly. So we've saved our configuration, and momentarily we should be able to confirm that our probe is producing metrics every 30 seconds because we have configured our template to turn on all the metrics the probe produces. We can also at this point look at our inventory that has been discovered. And recall this is what we hard-coded in our get updated inventory method. So here we see we've got a hosts folder that contains one host named host1 that has two measurements. We then have a guest folder attached to the host. We have one guest and one guest CPU. Let's go back now and look at the code that produced this just to see how it ties together. So here is the code in this create mock dataset that produces the inventory that we were just looking at. Note how we created a folder named hosts. We added one element named host1 to that folder. We created a guest folder underneath it, and then we added the guest1 and the guest1 CPU, and then we also set the metrics. In a moment we'll use Dr. Nimbus to view the messages that are being produced by the probe, and we should see that it's producing quaz messages for the 4 metrics that we are setting here. So now I want to verify that the quaz messages being produced by the probe are what I expect. So I've launched Dr. Nimbus, and I'm going to configure it to show me messages for probe VM simple. And all I want to see are the quaz messages. And let's start. So momentarily, every 30 seconds, we should see the probe is producing the 4 measurements that we defined. Alright, it looks like it has produced some messages. I'm going to go ahead and stop this now. Stop Dr. Nimbus, that is. And let's take a look at these 4 messages. So this one looks like the CPU usage for host 1. Notice the source target host 1 and the value of 0.34. Let's go back and look at the code and see where that was produced at. That was produced at line 181. Notice host 1 set metric CPU usage 0.34. Let's confirm that the other 3 metrics match up with these other 3 lines of code where we're setting metrics for guest count, CPU count, and CPU load. There is the guest VM CPU count, the guest CPU load percentage, and the guest count. So now that we've confirmed that the quaz messages being produced are what we expect, the next thing I would do is go back and I would work on modifying how my inventory is produced to actually go out to the device under test, gather the real data, and produce my inventory and metrics in a dynamic way. So going back to the source code, what that means is I would replace this create mock dataset method with some real logic that actually went out and collected the real data. This mock dataset method is just a good way to quickly proof of concept that the manner in which you're going to present your inventory and metrics is going to satisfy your requirements. In this video, we demonstrated developing a new probe from a probe template. This included defining the inventory and metrics and bulk configuration in probe schema XML, writing the code required to produce the inventory and metrics, and demonstrating the finished probe by deploying it to a robot.